This short video is to describe how NerveCenter is different than most monitoring systems. The goal here is to show you the very basic concepts of how NerveCenter works, and the way we're going to do it is to show a very simple monitoring concept that all monitoring systems need to provide, and that would be the very basic up-down monitoring capability. I'm going to show you how NerveCenter takes even this most basic of monitoring concepts to a more advanced level, taking into account more scenarios for the states that a node could be in besides just up or down. As we know, the world is not quite so binary. A node could appear to be up, but the operating system is not running. It could be locked up. A node could be up, or its application isn't running, and therefore it's kind of useless to you. NerveCenter can monitor all these things: the applications, the operating systems, the hardware, the network components. Let's take a look at the basic fundamental building blocks of NerveCenter, and those are known as models. This is an example within our client user interface. This is what a model looks like. It's also referred to as a finite state diagram. Finite state is the technology that NerveCenter uses that is a differentiator for our product. The concept of finite state means that instead of just polling for a metric or a value, or even if you're polling for multiple values, the concept of finite state means I can poll for any number of things, and based on that decision move to a different state that says I'm up, I'm down, or something in between, or any number of other conditions. This particular model is one that comes with the product, it ships with the product, and it is just for that purpose, for basic up-down monitoring of a node. All models start at this point right here called ground. If you create a new model from scratch, that's what you get, just that one state, ground. And then you need to decide, well, what is it I'm looking for? What conditions do I need to know about to be alerted or logged or whatever? In this case, we're starting at ground. Our end goal is to find a device down. But along the way, we could reach other states, and the end state may not be a device down. It may be where the SNMP agent is just not working, or it doesn't appear the device is down. It appears I'm just unreachable, that I just can't get to it for some other reason. At first glance, these models may look a little complicated, but I think you'll see as I walk through it that it's really not. Let's start here at ground and take a look at what we're doing to test initially off of ground. First thing we're doing is a 5-minute poll, looking for just a simple MIB object to see if it's even there at all, if it responds. If it does, this concept of fire trigger is how we move from state to state. In this case, we're moving from ground right back to ground. If the agent is up and life is good, we're going to stay right here and not tell anybody about it, because the agent appears to be up. Therefore, more than just the node is reachable, its operating system is running because the agent is responding. Let's say we get an error of some sort. We didn't get that response. We're going to go ahead and move to this error condition. And at this point, NerveCenter actually backs off and polls for that device faster. In this case, we're going to back off and poll at a 1-minute interval instead of 5. You'll see this is really the same poll, but it's a different rate. We're polling at a 1-minute interval. If we get a response, we'll move right back to ground and just keep on testing at 5 minutes. If we get another error, we move to this state called unknown. Unknown simply means, well, we've tried SNMP and it doesn't seem to be working. Let's try something else. Let's go ahead, switch gears, shift protocols. Let's try an ICMP echo. I didn't call it a ping. Most people would call an ICMP echo a ping, But a ping and a response is not what we're going to look for. NerveCenter is one of the few, perhaps only products that I'm aware of that looks intelligently at the rich information coming back from an ICMP echo request. In this case, we may get a response. And if we do, well, that's going to tell us, well, it looks like maybe the agent is down only. I can ping it. Node must be up. Let's not declare it down. Let's call the agent down. If we happen to get an unreachable message, then there could be a number of them. Let's not, again, call the node down and alert someone. Let's call it unreachable. Our monitoring of the rest of the network should detect that in one node that really is down, that's perhaps a switch or a router in front of these other devices that's causing those others to be unreachable. In this case, we'll put all the nodes that we find unreachable in this bucket over here called unreachable, or this state. If we truly detect a node down through an ICMP timeout, that's telling us, well, all the connectivity appears to be there, but the node itself just isn't responding, and at that point we'll do an alert and let someone know through some mechanism that that node is down. Now if we double click on this transition, we can see in this case the default is to do an inform to another system where alerts are being seen. We can suppress that node now from any other monitoring because it's down. Why try to monitor for anything else? We can do other things. We can open tickets. We can log to databases. We can send emails, send pages or text messages. Any number of things can be done from one of these transitions. We can even fire another trigger that goes and looks for, in another model, some other value. We could do a lookup at this point in a database to see if maybe that node should be down. It's in a maintenance window. It's been assigned to a maintenance window. On this transition here, going to unreachable, we could do nearly anything. Collect those nodes and find out if there's something common. Perhaps there's a single site that's unreachable, and we could create an alert that says it appears this site is down or unreachable. Okay, so that is how this model works. I think we've shown that that is far more, takes into account far more potential conditions of a node being down. This will reduce the number of false positives, even potentially reduce false negatives, because a node could respond to a ping but still be locked up. The operating system may not be running. The NIC card responds to the ping. In our case, we're testing first to make sure the operating system is responding, and we would detect it as being down. In any case, we're going to go ahead and get ready to do our next video. Please join us for more informative videos about how NerveCenter works. Thanks.